Hello students, in this session we shall discuss refraction of light from chapter 10 of class 10 science. Now what is refraction? You see, we know that we have learned in earlier classes that light travels in a straight line, but when light changes its medium, then its direction is changed to some extent, and this change is called the refraction of light. Remember, when light changes its medium of propagation, and then when it changes its medium, it changes its direction to some extent, and this is actually called the refraction of light. Alright, I am showing by drawing a glass slab. You see, this activity is also shown in your book. Suppose this is a glass slab. Now the light ray is incident in this point. Now you see, first I want to say that there are two mediums. See, light traveling in air before entering into the glass slab. The light is traveling into the air, and it enters into the glass slab, and after that the light will leave the glass slab and again go into the air medium. So see, there are two mediums, and the properties of the two mediums are not same. The refraction of the light depends on the properties of the medium. See, air is lighter than the glass slab. The density of the glass is greater than the air. It is obvious. So definitely there will be some change. So lighter medium is called the rarer medium, and the medium which is dense, comparatively dense, this is called the denser medium. So there are two medium, rarer medium and denser medium. Rarer means lighter, whose density is less. Lesser density is called rarer, and more density is called the denser medium. Now light ray is entering from by traveling from the air, and when it incident here, the direction of the light is changed to some extent. See, it was likely to go along this direction, but it has changed some direction. Now where it is incident, we can draw a normal according to the law of refraction. Now see, when the light ray incident, the direction of the light is that the light ray bends towards the normal. You see, the ray is likely to go in this direction, but it has changed direction and it has bent towards the direction, towards the normal ki taraf ye chala ja raha hai tarah. But when it leaves the glass medium again it has changes its direction. Now according to this, it was the light ray was likely to travel in this direction, but here we can also draw a normal. But when it leaves the glass medium and again enter into the air medium, this light ray bends again, and it bends away from the normal. You see, this is the normal. Here also it is the normal is there. So when it goes away from the normal. This is the difference. So what is this? You see, when the light ray enters from the rarer medium and enters into the denser medium, the light ray bends towards the normal, and when light ray travels from the denser medium and enters into the rarer medium, then the light ray bends away from the normal se dur ja raha hai. All right, now if we take extend this, somehow these two lines are parallel. If you draw it this error free, then you will get these two lines are actually parallel lines. So this is actually refraction, and this activity is also shown in your book, Refraction of Light through a Glass Slab. So I hope you can understand the refraction. What is refraction actually? Now there are some laws of refraction, like laws of reflection, reflection. There are laws of refraction is there. This is also called Snell's law. These are asked in your exams. See, the incident ray, the refracted ray, and the normal to the interface of the two transparent media at a point of incidence all lie in the same plane, and the ratio of the sine angle of incidence to the sine angle of refraction is constant for a light of a given color for the given medium. This is also known as Snell's law. Now, this is the laws of refraction. Now, next topic is refractive index. What is refractive index? So, refractive index actually, see, the light rays are bending when changing the, you have seen the, when it is changing the medium, it is bending towards the normal or away from the normal. So, to some extent, it is bending to what extent? The light ray is bending to what extent? This extent actually is called the refractive index. मतलब कितना गया है ये, कितना इस तरफ बेंड हुआ है और कितना उस तरफ बेंड हुआ है, वो जो मेजरमेंट है, that measurement is called the refractive index. Okay, and this is a constant term. It has no unit. Actually, this is a ratio. As per Snell's law, this is actually this is also a ratio of the sin I by sin R. You see, this sin, if I is the angle of incidence and R is the angle of refraction, then sin I by sin R is constant. Anyway, refraction is also you see, to extend of the change in the direction that takes place in a given pair of media is expressed in terms of the refractive index. So refractive index is also linked to the physical quantity of the relative speed of propagation of light in different media. That means relative speed, at which speed the light is traveling in different media. This is also can be measured with the refractive index. That means refractive index gives the comparing quantity of these two velocities. See, the speed of light in the air or vacuum is 3 into 10 to the power 8 meter per second. You know this, the speed of the light. But when it enters into the water, when it enters into the glass slab, this medium will be changed and the speed will also be changed. And remember, when light enters into the denser medium, the speed is comparatively less. So definitely, when the speed of the velocity of the light or speed of the light in air will be greater than the speed of the air in glass. Alright, so by refractive with the help of refractive index, we can find this, or we can compare this. Suppose a light is traveling with a speed v1 from the air and it enters into the glass medium and its velocity changes to v2. Alright, this is medium 1 and this is medium 2. Then we can say that n 2 1, that means the speed of the light in the medium 2 with respect to 1, this is represented as 2 1, is equal to this is the radius speed of the light in medium 1 and divided by speed of light in medium 2. So these are actually v1 by v2. And what will be the n12? That is speed of the light in the medium 1 with respect to 2. In this case, in the second case, you see the speed of the light when light is traveling in the glass medium. So this is medium 2 and this is medium 1 again. So it will travel with the speed, and when it enters into the air medium again, so the speed will be changed. Then in this case we can find n12, that is speed of the light in the medium 1 with respect to 2. So this is speed of the light in medium 2 by speed of the light in medium 1. So this is just converts V2 by V1. So this way we can compare or find the relate the refractive index of the speeds of the light in different media. And in general there is a formula Nm, that is speed of the light in a medium, particular medium, is C by V. This is also given in your book. C means speed of the light. This is actually speed of the light. And this is speed of the light in air, and speed of the light in medium. Medium means given medium. Usually the light enters in medium from air. That's why this is given. Okay, now there is you see, the absolute refractive index means the medium or index of a medium is simply called its refractive index. So 10.3 gives the refractive index of some material medium. So this you can learn. Try to remember some important refractive index of the medium. This may be asked in your exams. So I hope you got the refractive index. Actually refractive index is nothing but to what extent the light ray has bent towards the normal or away from the normal. This is actually called the refractive index, and it is a constant term. Next, we see the refraction of the spherical lenses. You see, refraction of the spherical lenses. As you have seen the spherical mirror, there are spherical lenses are also there. See, this is convex mirror and this is concave mirror. And as you see, the light rays are coming parallel to the principal axis. There is also a principal axis, and I am showing the structure of the lens. You see, this is convex lens. This is the principal axis, and the midpoint of this line is called the optical center. This is exactly the midpoint of the lens, and this is called the optical center. And center from the optical center of curvature will be this arc. The center of this arc will be the center of curvature in this side, and center of this arc will be the center of curvature in both sides. And focus, you know already, the midpoint of you have seen in the mirror the midpoint of pole and center of curvature. In this case also, focus is the midpoint of the optical center and the center of curvature, both sides. Okay, this is C and this is F, C. Actually, there are two center of curvatures and two for C in both sides. This is the optical center principal axis. So these rays are coming parallel to the principal axis, and after getting refracted in this lens, after passing through the lens, it is refracted, and all the rays are meeting together. All the rays are meeting in a point, in a same point, and this is actually nothing but the focus of the point. In focus they actually meet, and you see the rays are converging here. After refraction, the rays are converging here. That's why this convex lens is called the converging lens, in other words. Similarly, the concave lens, also optical center and focus like convex lens, and when the rays are coming parallel to the principal axis, after refraction, it is diverging. All rays are diverging, and when it extend in the backside, it meets in the focus. So as the rays are getting diverging, as the rays are diverging after refraction from a concave lens, that's why this concave lens is also called the diverging lens, in other words. Alright, so converging lens and diverging lens, this you must remember. And you see the table 10.4 and 10.5 is showing the nature of the images formed in case of convex lens and concave lens. See, these are the position of the object, position of the image, relative size and nature of the image. This if you go through the table you can understand. Now like mirror, there are some ray diagrams you need to remember in order to show the formation of image in case of concave lens and convex lens and concave lens. These ray diagrams you must understand. You see, number one, a ray of light from the object parallel to the principal axis after refraction of a convex lens passes through the principal focus. This is you see the rays are coming parallel to the principal axis. After refraction it is passing to the principal focus. In case of concave lens, you see rays are after refraction it is diverging, and when you extend it meets the focus. So there this way there are some other ray diagrams are there. You can go through this. Now I am showing you the ray diagram, how to draw the ray diagram. Mainly these are asked in your exams, but how will you draw a error free ray diagram of a showing the formation of image in case of convex lens and concave lens? So first we shall draw a line. Principal focus we must draw. Let's take up to 14 centimeter I am taking. Alright, without moving scale, first to take the midpoint. See, midpoint is 7. Okay, and mark 2 points which are equally placed. Suppose 2 centimeter apart I have taken, mark 2 points in both sides. Alright, now I shall draw the lens. First you draw this arc by placing here, by placing this center. So my lens is ready. Erase this extra part and simply you draw a line by joining the two intersections. Afterwards you can remove this line, or you may not, need not remove this. If you want to keep it. Alright, now I am placing the object. I shall place the object beyond the C. So here I take 1 centimeter because the lens is small, so I have taken 1 centimeter height of the object. See, this is O, optical center. Okay, and this is the center 1, this is the center 2, this is the focus 1, and this is the focus 2. Sometimes these centers are also called 2f1 because it is double the focal length, that's why, and it is also called 2f2. Anyway, now we shall show the ray diagram. Now see, these rays will go parallel to the principal axis. Make sure these are parallel. This is the point of refraction. Now after refraction, as per the diagram, it will go through the focus. The ray will refract it and go through the focus. See, this is the direction. Okay, and another ray will go through the optical center. Okay, now see, these two rays intersect here. So this is the image formed we got. Now there are some properties. You may refer these properties. You see this one I have drawn, and this is the object is placed beyond C. See, beyond 2f1. C means 2f1. So image is formed between f2 and 2f2. So f2 and 2f2, it is image is formed. All right. If you draw the error free, then it will definitely match to the table. So you try the other diagrams for the convex lenses. Now I'm showing another for concave lens. You see, concave lens is also same, but little different. It will be different from the concave lens, a convex lens. Similarly, you take any measurement. Again, I am taking the 14 centimeter here. You can take the different measurements. This is not, it doesn't matter. Just remember the optical center should be the midpoint, and the focus and centers should be placed equally at equal distances. So this is the optical center for the concave lens, and for concave lens we have to take 2 points. Well, first we should mark the focus and center of curvature. 2 centimeter apart I have marked it. Okay, now around the optical center I have placed another 2 points, suppose from 2 centimeter apart in both sides. Okay, why I have marked? Now you can understand. This marking is not required in case of convex lens, but concave lens it is required. You see, this way by placing here I have to draw this. So in order to draw this midpoints may be erroneous. That's why I have marked 2 points already to draw the exact diagram. Now draw a midpoint which must be perpendicular to the principal axis, and then you join this way and this way. Now it is the extra parts. See, concave lens is formed. Okay, this is optical center, and this is C1 F1 C2 F2. Okay, now place the image. Here also I am placing the image. Here I am placing the image. Object is placed between 2f2 and f1. Sorry, here I am placing. This object, you see, this condition I am doing. Now the ray will pass through it. After refraction, the rays are divert, but it should be drawn with the point of focus. Rays passing through this, and after refraction it will go in this direction. But if we extend this, it will pass through the focus. Then another ray passes through the optical center. and in optical center if rays are passing like this. Okay, now the rays are intersect here. You see, this way image is formed. So this is the formation of image. These are the formation of image in case of convex lens and concave lens. Okay, now nothing these are nothing so difficult. You just practice this. If you practice a lot, then this will be easier, and these diagrams are frequently asked in your examination, so you must be ready for this, to draw the erroneous diagram, error free diagram, sorry. Anyway, thank you.